Have you ever felt that intense burning sensation in your muscles during a really tough workout, and perhaps blamed it on lactic acid buildup? While this feeling is very real, the answer to whether the sarcoplasm produces lactic acid is no, it does not. Instead, muscle cells produce lactate as a byproduct of anaerobic metabolism, especially during high-intensity exercise when oxygen supply cannot keep up with energy demand. This distinction between lactic acid and lactate is an important nuance in muscle physiology. The core mechanism behind this involves glycolysis, which is the breakdown of glucose for energy, occurring in the sarcoplasm, the cytoplasm of muscle cells. During glycolysis, glucose is converted into molecules of pyruvate. When there is sufficient oxygen, pyruvate moves into the mitochondria for further aerobic respiration. However, during intense activity when oxygen is scarce, pyruvate is converted into lactate by an enzyme called lactate dehydrogenase, or LDH. This conversion regenerates NAD+, allowing glycolysis to continue producing a small amount of ATP, or adenosine triphosphate, which is the cell's energy currency. The traditional term lactic acid was a misconception, as lactate is the predominant form found in the body at physiological pH levels. Understanding this process helps us appreciate how muscles adapt to different demands. Lactate is not just a waste product, it is a valuable energy substrate. It can be transported out of the working muscle cells and taken up by other tissues, like less active muscles, the heart, or the liver, where it can be converted back into pyruvate and then used for energy or even synthesized back into glucose through the Cori cycle. This lactate shuttle mechanism ensures that energy can be efficiently recycled and utilized throughout the body, helping to sustain activity even when oxygen is limited. The role of lactate dehydrogenase, or LDH, is pivotal in this process, ensuring that glycolysis can continue, providing a rapid but limited burst of energy. Another important concept related to lactate is the lactate threshold, which is the exercise intensity at which lactate production exceeds its clearance from the bloodstream. Training can improve an athlete's lactate threshold, allowing them to sustain higher intensities for longer periods, demonstrating how understanding these metabolic pathways can impact performance. By recognizing that lactate, not lactic acid, is the actual metabolic product in the sarcoplasm, we gain a clearer picture of muscle metabolism during exercise. This knowledge helps to demystify the burning sensation often associated with intense effort, reframing lactate from a harmful waste product into a dynamic and essential player in energy production and intertissue communication within the body.